What does probability mean?
Chances of.
Chances of, yeah. What else? What does chance mean?
Like multiple opportunities.
Multiple opportunities?
Out of.
It is out of. What do you mean by out of?
Like out of your total like attempts
Ah.
or something.
Out of some total. Yeah, that's really important. Okay. Now, how do we determine these chances? These opportunities, these totals? So that's a big question. So kind of a general definition of probability. It's a measure of your belief that something will happen. So the big thing we have to figure out is how do we measure that belief? And measuring that belief has to do with opportunities, it has to do with totals. Okay? So the measurement is a ratio of what we call favorable outcomes to total outcomes. So probabilities are fractions in a sense. Sometimes we express those fractions as decimals, sometimes as percents. What's the probability the sun will shine right now? 100%. It is shining right now. What's the probability it's raining right now outside this door?
0.
0. It is not raining, right? So another thing about probabilities, if something can't happen, that means there's no numerator. If something does happen, the numerator and the denominator are the same. So probabilities can be between 0 and 1. If something absolutely happens, it's going to be 100%. 100% is the same as 1. If something cannot happen or does not happen, it's a 0. So probabilities as decimals are between 0 and 1. As percents, they're between 0% and 100%. So think for a minute about a probability that is relevant to you. I just thought of one. Want to hear mine? What's the probability that I survive the coronavirus? Well, I'm not too old. I'm reasonably healthy. And so I bet it's about 99.9% that I survive it. Okay. What's the probability I survive the flu? I think it's about the same. Pretty close, 99.9%. Okay. Could the flu kill somebody? Yeah, it does kill people. And there's usually extenuating circumstances related to that. Sorry, that was kind of morbid, but the coronavirus is going around. It is in our county. It is something we need to think about. Wash your hands often. Don't stick your fingers in your eyes. Don't suck on your fingers. Okay. So, other probabilities. Anybody think of one that's relevant to them?
Probability of passing this class.
That's a good one, yeah. So,
Yeah, right, you wish.
okay. actually, there are lots of coronaviruses out there. Like, for example, I had a cat die last year of complications from a coronavirus. You ever hear of a disease called FIP? Feline infectious peritonitis? Is that what it stands for? Anyway, that's symptoms related to a coronavirus that affects cats. So there's lots of coronaviruses around. Some of them affect humans, most of them don't. This one jumped from animals to humans recently. It's new to our population, and so we're kind of freaking out about it. Most people don't need to freak out about it. If you do some research on the probabilities, you'll find that most people are okay. What else? Probability.
The probability I'll get on like concrete projects done in time.
Oh, that's a good one. Probability of getting projects done. So, for example, I make to-do lists of things I need to get done. And sometimes they're a list I make for the week, but I hope to get a lot of it done in a particular day. Otherwise, I make the list for a day. And when I do it that way, I generally exceed my expectations. But the week ones usually, a lot of stuff to do. And I'm not going to get most of it done at any particular day. So it turns out, without even thinking about it, we do probability stuff in our head all of the time. Think about when you're crossing the street. Do you look around before you cross? Do you ever make a decision about, well, it doesn't say I can cross, but I'm going to anyway?
Yeah.
Right? Because we're thinking, there's no cars in sight, the chance that I get hit is pretty low, right? And we go and cross the street illegally anyway. So we're always making these calculations subconsciously. Okay? So now we're just going to take some of that subconscious calculations that we do and put it out in the forefront. And animals even make these calculations. Okay? Now they don't think about them as calculations, but they still do them. Probability, the hard part about probability is counting. What? I know how to count 1, 2, 3, 4, but you got to count the right stuff, and that's the hard part, deciding what needs to get counted. When we're counting stuff, deciding what needs to be counted is related to an idea called what we call the sample space. And the sample space is just like a list of all outcomes.
Is that why usually just like this popped into mind, like marbles. I know marbles are used like so much with like children or just anything in general.
Yes.
How it'll list like the color marbles, and then like sometimes it'll ask you for like in total or just in.
Yeah, because marbles are kind of easy because you can have a bunch of them. But you could just say there's only 2 colors, right? So it's kind of easy to count, and so they're used a lot in examples in terms of that. And crossing the street is like that. Cars are like marbles. Are there any cars around? No cars. I can walk. Right? There's a few cars. Maybe I'll run. Anyone ever run across the street when you're not supposed to? Right? We all do that kind of thing. Okay, so we're counting marbles, right, in a fancy kind of way. So sample space is an important idea, knowing what you're counting. Okay. So those of you online, you're just going to have to wait for a second. I have a deck of cards that I shuffled a minute ago. You'll have to take my word that I shuffled them. I'm going to give you each a card.
Are we allowed to look at it?
You are allowed to look at the card. Okay, so.
Can I guess our cards?
No, I'm not going to guess your cards. I'm not good at party tricks like that. Okay, so hold up your cards so I can see them all. Okay, turn around.
Oh, you want to see it?
I want to see it,
Oh.
yes, so I can see your card. Okay, Jack of diamonds, 8 of diamonds, 7 of hearts, 10 of diamonds. I'll see what you got. King of diamonds, 4 of diamonds. What's weird about this collection?
They're all diamonds but one.
They're all diamonds but 1. What else is weird?
Wait, what?
Is that not weird? So again, the cards that I saw, what's that?
I said maybe you didn't shuffle.
Maybe I didn't shuffle the deck, right? There was a Jack of diamonds, there was a 8 of diamonds, I think there was a 7 of diamonds, there was a 10 of diamonds. Who had the heart? What was it? 7 hearts. Oh, maybe that was this one right here. Hearts. What did you have, Olivia?
4 diamonds.
4 of diamonds, 4 of diamonds. Okay. They're all red, too. There's a lot of diamonds. Okay, so maybe I didn't shuffle the deck. So I mentioned before, probability is a measure of our belief. I was believing there should have been some black cards out there, and there weren't. My belief was defied. So something's wrong. Either I didn't shuffle them, or there's something wrong with my deck.
You only put like a few black ones.
Yeah, there's not many black cards in it. Yeah. So, another game. So I got a set of dice here. You got a set of dice. Olivia has a set of dice there. If you guys could each roll your 2 dice, I'm going to get a pair of virtual dice here. Oh, you got dice too. You roll your dice too. Alt-tab. Oops, wrong button. There we go. Let's see. Random dice. Random.org. Give me 2. Roll the dice. Okay, so I rolled the dice. I got a 2 and a 3, which adds up to 5. What did you get? 5 and a 1 adds up to 6. What did you get?
4 and 1.
Adds up to 5. You
I
got
6 and a 5.
holy crap! So you get 11. Okay, so let's do it again. Everyone, roll your pairs of dice that has dice. I got a 4 and a 2. That's a 6. 5 and a 2. 7. You beat me. What'd you get?
3 and 1.
Ooh, you got a 3 and you
I
got
got a 5 and a 2.
5 and a 2. We tie. Oh no, you tied her. Okay, let's do it again. Roll again. 5 and a 2. I got another 7. You got a 4 and a 2. That's a 6. You got a 5 and a 3. That's a 7. You got
11.
11.
5 and 3 is
You
8.
won. Oh my gosh. What's that?
I said 5 and 3 is 8.
Oh yeah, 8. That's right. So all kinds of things can happen when we roll the dice. Is rolling 2 dice a predictable event in some sense? Like, could we list all possibilities? Yeah, we could. There's 6 on one dice. There's 6 on another. How many total possibilities do you think that is? Not 12.
36.
Turns out 36, and we'll see why in a little while, how to draw that out. Yeah, there's 36 possible outcomes. If I'm only looking at the total, that narrows down the outcomes a little bit. Okay, because are there 36 different possible sums? No. What's the smallest sum you could get?
2.
2. What's the biggest sum you could get? 12. 2 to 12 is how many different sums?
No.
11. Well, 12 minus 2 would be 10, but that's not counting the 2. Yeah, so there's 11 different sums there, but there's 36 ways those sums can happen. So is each sum equally likely? Probably not. And we'll figure out what that means. So equally likely is an important thing. All right, let's do coins next. I got a couple of coins here. So you guys didn't get to play. You get 2. You get 1. Sorry, Elsie gets 2 because she hasn't been here in a while. Okay. So I'm going to get a random coin here. What do we expect to happen when we flip a coin?
Heads or tails?
Ooh, Google has a cute little coin flipper. All right, I got a tail. Flip. I got a head. What's the next one have to be then? A tail, right? What? It could be either? No, I told you it had to be a tail. Next one's got to be a head. Watch. Ah, I was wrong. Okay. Yeah, so now flip your coins. What do we get? All 3 of those.
Tail.
Tail?
Tail for 1. Tail for
Tail for the other one. Okay. So lots of things can happen. How do we keep track of those things? Carefully. So one thing we're going to have to do when we're playing with probabilities, we're going to have to make some lists. Another thing we're going to do is draw trees to kind of figure things out. That's going to help too. And make tables. So let's just make a simple tree for Elsie's problem. I gave Elsie 2 coins. I'm wondering what can happen with 2 coins. So let's just brainstorm a little bit. What would the sample space look like? What's an outcome look like when I flip 2 coins? So I got 2 coins. A trial is when you watch something happen. In this case, a trial is both coins get flipped. And then Elsie said, like, what is an outcome here? Elsie said she got a tail on one, and she got a tail on the other. Can you flip them again?
You go to tell one. Heads on the
Okay, so she got a tail. Do it again, please.
Want me to do it again?
Yep.
Head.
Head on that one, and
Tell.
tail on that one. Okay. So far, we see she can get a tail and a tail. She get a tail and a head. She get heat. No.
Okay.
Head. She get a head and a tail. Anything we're missing here?
Head and head.
She get a head and a head. Now, are there other possible outcomes? Did I list more outcomes than I should have? According to this, how many outcomes are there? 4? Are there 4? Are there more? Are there less? 3, maybe? So the question is a tail head different than a head tail?
It depends. I mean, it's
Depends
something
on what?
different with the order.
The order? Does order matter? Are they the same coin? They're different coins, then order matters. Yeah. So we'd have to name the coins, like I named my dice, right, George, over there? Yeah, so she would have to name her dice to keep them straight, or coins. Would it make a difference if she was flipping a quarter and a penny instead of a quarter and a quarter?
Yeah.
That would make a difference?
Yeah. The weight is different. You could
So a penny would more likely go to heads than a coin would, or?
Well, we don't know that, like, but
Okay.
I mean, they are different. I mean, even
So-
if it is the same coin, like you said, you have to identify them separately to
So that's
keep your.
Another question that comes up is a coin fair? When we say is a coin fair or dice, we're referring to the idea of are the outcomes equally likely? Okay, so we're going to brainstorm that right here. So when I flip a coin, I usually believe it's fair, and that I'm just as likely to get a head as a tail. So when I look at this scenario here, I see 4 different outcomes. I have no reason to believe it's unfair, so I'm going to believe they're fair. If it's fair, that means each has the same chance of happening. So this one right here has a 1 in 4 chance of happening. This here has a 1 in 4 chance of happening. That has a 1 in 4 chance of happening. And that has a 1 in 4 chance of happening. So if I'm right about this, I could approach somebody that doesn't know as much, and I could say, well, you could get 2 tails, 1 tail, or no tail. I'm clouding the situation when I say that. And the person might say, oh, I like the idea of 2 tails. Oh, good, I pick 1 tail. So if there's 2 tails, you win. If there's 1 tail, I win. That seems fair, doesn't it? At first glance, yeah. Is it fair according to this chart? No, I would have a 50% chance of winning. He would have a 25% chance of winning. And there's a 25% chance something else happens, right? So the hard part I mentioned about probability is counting things correctly. And it takes a little practice in doing that. And I've been doing probability a lot, and you guys can easily ask me a question about probability that I couldn't answer in a day that sounds like an easy question, but it turns out counting it's complicated. So we're just going to scratch the surface on what we can do with probability. The basic idea here is back to the beginning. One more back. Is that probability is about measuring something happening, and that measurement is a ratio. So we're just playing more with fractions and decimals. And that's the main reason we're doing this. Just more practice with fractions and decimals. So I'm going to stop this video in a second. For those of you who aren't with us, there is an activity you're going to work on online. Find yourself a partner to do this with. How many do we have here? 1, 2, 3, 4, 5. That's okay. We can make it work. I forgot to post the activity. Okay. I will, let's see, I put it on a different place. Okay. I printed it out and I posted it on my online notes, but I forgot to put it on our Canvas website. We'll do each one of these. So I designed 3 different spinners. each spinner has a different set of numbers. You're going to pair up, actually, I'll play too. So somebody gets to play with me, and then otherwise you're going to pair up. Each person's going to pick a spinner. If there's a dispute about who gets what spinner, you're going to flip a coin to settle the dispute. Okay? Because each spinner is different. They all have their pros and their cons. What we're going to try and do by the next class is figure out which is the best spinner to pick. We're going to try and figure that out. So the first version of the game that we're going to play today is that somebody's going to pick, say, spinner 1, somebody else says, I pick spinner 3, and then you guys are going to spin against each other. The person with the highest number wins. You're going to do that at least 20 times. You're going to record on paper. Each of you is going to do your own recording. For trial number 1, what did you get? What did your neighbor get? Did you win or not? Okay, so you're going to make a table.
Do you want this one here on a piece of paper?
You can put it on the back of that or another piece of paper. And then we're going to try and answer some questions. Like for your spinner, like say you pick spinner 1. What's the probability of getting a 1 on your spinner, according to your 20 trials? What's the probability of getting the 9? What's the probability of getting the 5? If somebody played against you on spinner 2, what's the probability that you beat them? Is it 50%, 30%, 40%, something else? Okay. So we're going to experimentally try and figure this out. Next class, we'll try to do it more systematically than just experimenting. And then what would happen if all 3 spinners play at the same time? Is that different than two on 2? Or 1 on 1, sorry. As for spinners, you're going to make your own spinner. And the cheap version of a spinner is a paper clip where you pull up one end so it's got a pointer on it. And then you put your pen through the loop in the middle of your spinner and flick it. Does that make sense? Okay. So you're going to use a paper clip to make a spinner. I got some paper clips here. And then we're going to decide who's going to work together and who's going to work with me. All right, paper clip. So everybody needs a paper clip. When you spin it, you want to do it put the paper on the desk, not on your notes, because the shape of your notes is wavy and will affect the spinner, maybe adversely, maybe in an extra way. I give everybody a paper clip. So. Okay. And then again, before we start, after I bolded one of the directions here. I would like you, once you and your partner pick a spinner, I would like you to make a guess as to whether you or your partner might win more often based on the numbers you see on your spinner. Okay? And try to say why. And your answer could be, I don't know, I just guessed. But try to come up with a better reason than that once you each pick one. Then do your 20 spins. Your table, everyone's going to make their own table. Your table will look something like this. You're going to have 4 columns. You're going to have a column for the trial, which is each time you go against each other. You're going to have your result. You're going to have your partner's result. And then you're going to have, for you, a win or a loss. Okay, so maybe for the first trial, I had spinner 1 and I got I think 5 was on there. What's on spinner 2? Is there a 6 on spinner 2?
Mm-hmm.
And then your partner got a 6. So if this is you lost. Then you spin again. And this time maybe you got the 9, your partner got the 2, you won. Every time you have a loss, your partner has a win. So that column will look different, and the columns for you and your partner will be reversed. That's okay. But I need each of you to have your own record of what you got, what your partner got. Okay? So everyone's going to keep an accounting of this. You'll likely turn this in before you. No, we probably won't be able to turn this in before you leave because we're almost out of time. But we should be able to get at least most of it done. And then we'll work more on this next class. All right, video stop.